Hello boys and girls, Mr. Giomini. Wanted to come to you with another video here for topic 6, dealing with percents. A lot of this was covered in the Socrative, or little bit parts of it, gives an idea. And really lesson 6.6, as with all the final lessons in all of the topics we've done, take all the skills and really apply them to real world situations. How you might use this on a job, when you go to purchase something, just how you use this in your day-to-day life. Let's take a look at a couple here. We have 65% of what number is 78. Now remember, if I told you, I've talked about this but multiple times during this topic, if I had 5 groups of 4, everybody told me, oh, you had 20. What do I do to 5 to make and 4 to make it 20? Well, I multiply. Wherever you see that magical word of in these situations, we are multiplying. I'm going to put a little multiplication dot up there. Now I know that I cannot multiply a percent with the percent sign on it, so I must use its decimal equivalent. The decimal equivalent of 65% is 65 hundredths. How do we get that? Well, all percents are out of 100. 65 over 100. Remember that bar in the middle there means to do what? It means to divide. If you wanted to, every single time you want to convert a percent to a decimal, you could simply say, oh, the part that you have over 100. Put the decimal there, put the decimal here, add multiple zeros. 100 does not go into 6, does not go into 65. It will go into 656 times, which gives us 600. I now subtract. That's a 5, that's a 0. Annex down a 0, that gives me 5. Moving the decimal 2 places over to the left when trying to convert a percent to a decimal saves us a lot of time. That's why we use that little method, little cheat, shall we call it. But there's the rationale. As I've shown in class, there's the rationale as to why 65% as a decimal is 65 hundredths. Now, going back to the problem, it says 65 hundredths of, meaning times. What number? Well, if they're asking us what number, we don't know. We'll just call it N for number. Is a fancy word. If I told you guys, hey, 7 plus 4. Whoa, my pen just jumped. 7 plus 4 is 11. 5 times 4 is 20. We know that is means equals. So no different here. We just have it in word form, equals, and it equals 78. Well, looking at this, it looks like I now have an equation. I have an equation over here. It says 65 hundredths, which we've transferred, went from percents to decimals. We call it now 65 hundredths. We have 65 hundredths times n, because we don't know what the number is. I'm going to put the variable next to the coefficient to the right of it. Remember, we're multiplying two terms, or two factors. One factor is a number, one factor is a variable. We always put the coefficient first, which is the number. And is equals 78. I have a one-step equation. This is going back to topic, I want to say 3 or something like that. It's a blend of topic 3 and topic 1, where we worked with decimals. I want to box in that n. I want to evaluate for 1 n, not 65 hundredths of an n. I will divide both sides by 65 hundredths. Divide by 65 hundredths. Remember, numerator goes in, denominator goes out. We've talked about this plenty, this topic. In this situation, the numerator, the part is 78. We have 65 hundredths, the denominator, as my divisor. All right. I notice immediately that I have a decimal in my divisor. I cannot have that. I'll move over once and twice. That now gives me a new divisor of 65. Division bar here. If I move it twice here, I must mirror that here, move it over twice here. It now gives me 7,800 or 7,800. Now I could do my division. 65 does not go into 7, but 65 goes into 78 once. That gives me a 65. I subtract. We'll bring down that 0 right now. 8 minus 5 is 3. 7 minus 6 is 1. 65 goes in 130 how many times? Well, I'm pretty certain that 65 doubled will give me 130. So it looks like I think 2 works. 65 times 2 gives me 130. Subtract that 0. I need to bring down that 0. There's nothing left here, but I need to fill that place value up with a 0. Answer is 120. About to sneeze here. Hold on. Excuse me. There's my answer, 120. If I wanted to check this, if I wanted to check to make sure my math is right, I could simply go 120 times the 65 hundredths times the 65 hundredths. Should give me an answer of 78. That is 0. That is 10. That gives me 6. Done with a 5. Put in a 0. That's 0. That is 12. That is 7. Hey, look at that. Oh, 7,800. That's not the answer. Oh, wait. Decimal. There's a way I could check my math to see it works. Math's a great thing. You can always check. All right, let's go to another one. We have a story problem. Doing what I just did now and applying it to a story problem. This is within our wheelhouse. We can do this. All right, taking a look at what we have here. A piece of ribbon is 21 inches long. 21 inches long. The piece of ribbon is hey, wait a minute. The piece of ribbon, this 21 equals 15% of the original. Look at how slowly I'm reading it, and I'm looking for keywords. It is 15% of the original. Wait a minute, that's same as 15 hundredths times the original length. I'll just call it of ribbon. I'll just call it R for ribbon. How long was the original length? I have my equation written right here. 21 inches equals 15 hundredths or 15% of the original. I have taken this ribbon and cut it up into chunks. The chunk that I have. So again, let's think about it here. Here's my chunk of ribbon. I've cut it up into sections. We know that this section is 21 inches long. That means this section is 21 inches long. And I continue. If this were 15% of the ribbon, this would be 30% of the ribbon, 45% of the ribbon, 60% of the ribbon. We have what? 75% of the ribbon. Hey, we have then what? 75, that gives me what? 90% of the ribbon? And then we have what? 100% of the ribbon. Let's see if I did my math right. Double, 15, add 15, add 15, add 15. Now you notice if I add 15 here, we no longer have percents, do we? But each one of these is 21 inches. Let's take a look at my math. 21 is equal to 15 hundredths times R. I need to solve a one-step equation. We've done this in the past. We just did this 30 seconds ago on that last problem. I'm going to box in that R. I want to evaluate for 1 R, not a fraction of an R or a percent of the R. Let's find out how much ribbon there is altogether. The inverse of multiplying by 15 hundredths is to divide. Remember, I'm going to write my fraction bar now. Numerator becomes my dividend. That becomes my 21. Denominator becomes my divisor. I cannot have a decimal in my divisor, so I simply move the decimal 2 places to the right. I'm timesing it by 100. We get 15. We must mirror that movement in the dividend, So we have 2, 1, add 2 zeros, that's 2100. All right, let's go do some math. Put a decimal point, I'll add 2 zeros just in case I need them. 15 goes into 2 0 times. What factor times 15 gives me close to 21? 1, which gives me 15. I subtract. That's 6, annex down a 0. 15 goes into 60. Well, 15 doubled is 30. 30 doubled is 60. So 2 doubled would be 4. That gives me 60. I still have a decimal point here. I need to fill in one more place value. Well, that's going to go with a 0. And there's my answer, 140. That means if I were to substitute 140 in right here, that would give me 21. I'm going to cheat and use a calculator to expedite this process. Let's take a look. 140 inches is the entire length of the ribbon. I have 15% of that. It should give me 21 inches. Yes, I have it right. Let's move on. This reminds me of a problem I kind of gave you guys with the aquarium the other day. Workers are loading boxes onto a truck. So far, they have loaded 48 boxes onto the truck. According to the inventory, they still need to load 96% of the boxes on the truck. How many boxes do they need to load on the truck? Let B equal the number of boxes the workers need to load on the truck. Drag tiles to complete the equation to solve the problem. Well, first they give me is 100% minus 96%. Wait a minute. That's the total once they're done. But it says they have this left still. That means they've only done 4% of the job. They've only completed 4% of the job. Now, we know that we can't multiply by percents, but we can multiply by their decimal equivalents. If I have 4%, that is 4 out of 100. And again, if I wanted to, I could simply show you that 4 divided by 100 would give you 4 hundredths. But instead of doing all that math, we just say, hey, move the decimal, which is right here in 4, 2 places to the left. We have power, or 10 to the second power. Divide it 2 to the left. So we're going to go 1 and 2. There's nothing here. We fill it in with a 0. This gives you 4 hundredths of the job of the box that's going to be loaded equals 48. All right, because they've only put 48 boxes in. To solve this, we have 4 hundredths times B equals 48. I've noticed a lot with this. I am dividing a lot with a decimal divisor. This is practice again from, I believe, topic 1. Divide by 4 hundredths because we want to evaluate for 1 whole B. We want to evaluate for 100%. We divide by 4 hundredths. I get 48 divided by 4 hundredths. Again, I see that decimal in my divisor. I must get rid of it. Simply by moving the decimal 2 places right, I'm multiplying this by 100. I multiply the dividend by 100. That gives me 4,800 divided by, hey, 4. This is some easy division. 4 times what factor gives me 4? 4 times 1. We have nothing left over. Let's move on. 4 times what factor gives you 8? 2. Any remainder? No. We have 2 place values just sitting empty. We cannot leave it there. We're going to put 2. The workers will load a total of 1,200 boxes. Now, if I were to ask you how many boxes are left to load, we would simply take the 1,200 that need to be loaded, and we subtract the 48 from it. Give me a grand total of 1,152 boxes still need to be loaded. Again, I'm taking the question and stretching a little bit. It's not what it's asking, but just getting you to see. You might see something like that in an assessment where they're asking you how much have they loaded, how much they still need to load based on what they give us. All right, let's move on. Rebecca wants to read a certain number of pages each day during summer vacation. Good for her. Today she read 204 pages, which is 136% of her goal. Wait a minute. She read more than her goal. 136% is more than 100. She outgained it or extended it an extra 36%. How many pages does Rebecca want to read each day? Well, I know it's not 506. The reason being, that's larger than 204. She read 136% of her goal. All right? These other 3 could be viable answers. All right, now, she read 136% of her goal. We don't know what her goal is. It's 136% of her goal, which we don't know, and that would equal what she did today, which is 204. Now again, I need to convert this to a decimal. This is a percent. We simply move it 2 places to the left. We're dividing by 100. 1 and 2. That becomes 1 whole, which is the 100%, and 36 hundredths, which is 36%, times G equals 204. We are now going to box in that G. We want to evaluate for 1 G. I don't care what 1 and 36 hundredths G's are. I want 1 G, or 100%. We'll divide both sides 1 and 36 hundredths. Divide by 1 and 36 hundredths. I have another decimal in my divisor. Remember, numerator becomes dividend. Numerator becomes dividend. It goes in the house. Denominator stays outside as the divisor. I have that decimal in my divisor. I move it 2 places to the right, 1 and 2. I must mirror that and move over here, so 1 and 2. This primarily becomes 20,400 divided by 136. Wow, I'm going to erase this so I have some space. I'll put a decimal here at the end, just in case I need it. Okay, I know 136 times nothing will give me 2, not a whole number. 136 times no whole number gives me 20. 136 goes into 204 1 time. I must be careful with my subtraction here. I believe 36 is 14 away from 50. 50 is 15 away from 200. So we have 214 plus 4. Or no, I'm sorry, gives me, no. That gives me 64. There we go. 64 plus 4, I think gives me 68. That gives me 14. That's 8. That gives me, what is that, a 9? That's 6. Yes, 68. I annex down a 0. 136 goes into 680. How many times? Well, based on this, because I have a 1 here, I know 75 can't be the answer. It's either 3 or 5. What might give me closest? Let's try 5. 5 times 6 is 30. We put a 0 here. 5 times 3 is 15. Plus 3 gives me 18. 5 times 1 is 5. Plus 1 is 6. Hey, look at that. We have no remainder. I need to still put a number here to hold that place value. We'll put a 0. The book, she was supposed to read just 150 pages a day. She was so into the book, she read 150. Good for her. Or 204, excuse me. All right, last one. A company mixes pecans, cashews, peanuts, and walnuts to make a batch of mixed nuts. About 15 4/10% of the mixed nuts in a batch are pecans. If a batch contains 77 pounds of pecans, how many pounds of mixed nuts are in a batch altogether? I'm really confused here. All these different things going on. Let's take a look. Okay, we have a bag with a variety of nuts. We have pecans, cashews, peanuts, and walnuts. We know that of this whole bag, 15 4/10% of the bag, right, are pecans. All right, 15 4/10% of this bag are pecans. The batch contains 77 pounds of pecans. That means, remember, this has also cashews, peanuts, and walnuts. Abbreviate here, my sloppy handwriting. So, 15 4/10%. That looks like a 16, Mr. Giomini. 15 4/10% of the entire bag, which I'll call B, is equal to 77 pounds of pecans. Look at that. I have taken this and written it into almost an algebraic sentence that I'm now going to translate into an algebraic equation. This becomes 154 thousandths. I'm going to call it B because I've converted this to a decimal by dividing by 100, move it over once and twice. That is equal to 77. I must divide both sides now by 154 thousandths. This is a lot of division. Nothing I can't do. I've been dividing now for a long time. Nothing you can't do. You've been dividing for a long time too, just not as long as I have. Now, I need to do a little division bar over here. Remember, numerator becomes dividend, which goes on the inside. Denominator becomes divisor, goes on the outside. Wait a minute, I cannot have a decimal in divisor. Must move over 1, 2, and 3, giving me a whole number of 154. I must mirror that move or mirror that multiplication of 1,000 inside. This gives me 77,000. All right, I'm going to erase some of this to give me some working space here. All right, let's take a look. Wow. I know no whole number times 154 will give me 7. No whole number times 154 gives me 77. All right, let's see here. 6 would be too big. Do I try 5? Let's give 5. I think 5 might be too big too. What could I do here? 154 times what gives me close to 770? Let's just try 5. 5 times 5 is what? 20? 5 times 5 is 25, plus 2 is 27. Oh, yes. 5 times 1 is 5, plus 2 gives me, look at that, exactly it. I have no remainder, but I must put 2 zeros here to hold the place value. That gives me 500 pounds in that bag. That is a big batch of mixed nuts. All right, hope this helps you out. Again, if I think about the test, if I'm looking forward into the future, I'm thinking these are types of questions that are on the second side of the assessment that sometimes we struggle with, that application piece. Now you have 5 decent examples based on how you think I am as someone who models things, and hopefully you have something that will benefit you going into Friday's test. I wish you well. Take care.